Hey guys, it's Miss Johnson here, and I'm here to talk to you today about linear programming. That's our learning target, is how do we set up and evaluate a linear programming model. So here's where linear programming fits in with this chapter. When we are looking at a linear programming model, we're basically looking at a set of inequalities that are all graphed together on the same coordinate plane, thus giving us a system. Kind of like this system that we see down here. We've got a system of inequalities, three of them, and they've all been graphed on this same coordinate plane. And this gives us a linear program. And what makes it a linear program is the fact that we are trying to optimize some sort of company, product, something. So a lot of real life problems use optimization, therefore needing a linear program. So by optimizing it, it means we're either finding the minimum or maximum. Obviously, if we're talking about something like labor costs or product costs that you need, you want to minimize it. When we get into profit and revenue, we want to maximize it. So it just depends on which part of the company you're looking at. A company may want to maximize their profits, so therefore we set up a linear programming model and they use an objective function, which we'll also talk about, to find the maximum profit possible and how they get there. The linear programming model consists of system of constraints, and that's what these inequalities are. These are your constraints. Okay, so the constraints give us the boundaries of the optimal function. Okay, so the system of linear inequalities and an objective function, and this is an objective function. Sometimes this is called the min or max function. And what you're going to see is that it's an equation that looks like this: f of x comma y equals whatever the equation may be. This is the objective function. It's not part of the linear inequalities that go on the graph. It's the objective function that we use after we graph the system. So if we're solving a linear programming model, then we need to graph the system of constraints. Then we find the vertices of the graph. So the vertices of this graph would be these corners right here. Basically the place where the inequalities intersect. So we've got a little triangle here, triangle because there's 1, 2, 3 inequalities, which means we have 3 vertices that we have to look at. And then we plug those vertices into the objective function to find the minimum or the maximum depending on whatever we're trying to find. Okay, so we're looking at a system of inequalities graphed together on a coordinate plane in order to find the maximum or minimum part. So let's take a look at example 1. In example 1, it says, graph the following system of inequalities, name the coordinates of the vertices, and find the max and minimum values of the function for this region. So here's our objective function. Okay, we're going to use that when it comes to the end after we graph these. And here's our constraints. Okay, so these 3 things are going to give us the constraints. Now, I'm going to look at graphing the constraints first. That's the first thing that I want to do. So when I graph these constraints, the top 2 are pretty easy. The first one is x is greater than or equal to 1. If I have x is greater than or equal to 1, that means I have a solid line, and I'm looking at a vertical line at the value of 1. So I've got a line that looks kind of like that. And we know that lines always go on and on and on, and there we go. So if I graph that one, that's what that one gives me. This is a vertical solid line. The next one is a horizontal line. The line y is greater than or equal to 0. So if I'm looking at y is greater than or equal to 0, that means I'm looking at the x-axis because my y hasn't gone up or down at all. There's no slope here, so it doesn't increase or decrease, and there's that line. The last one, I need to solve for y here. If I subtract the 2x, I end up with y is less than or equal to negative 2x plus 6. So I'm going to go ahead and graph that line. I need to put the y-intercept on the coordinate plane, so I go up to 6. The slope is negative 2, so I go down 2 and right 1, down 2 and right 1, down 2 and right 1, and there's that line. Let's see if I can get it with my line tool here. So I want purple line, and kind of like that. Oh, that was pretty good. Okay. So there are my three constraint inequalities. Now the question is where's the shaded region that goes with them? So with the inequality, the vertical line at the top, I wanted to shade greater than, which means to the right. And with the horizontal line in the middle, I wanted to shade up. And the bottom one, I wanted to shade down. So it's this little triangle right in here. Okay. That's the feasible region. That's what we call the feasible region. It's the region that fits all three inequalities. Feasible region. So then the next thing that we need to do is look at the vertices of that region. So if I look at the three corners of my triangle there, the vertices look like 0, comma 1. No, I lied. I'm sorry. 1, 0. I had those backwards. Go over 1 and stay on the axis. Then 3, 0 is another one. And this one up here looks like 1, 4. Okay, so I graphed the system, I named the coordinates of the vertices. Now I need to find the max and the min function for this region. So what that means is you need to take these three vertices and you need to plug them into the objective function. So if I look at that objective function, I'm going to plug all three of those vertices in. If I plug in 1, 0, it looks like this, f of 1, comma 0. That's just the notation. We don't do anything with that mathematically. We just use that as the notation. I plug in 1 for x, so that's 3 times 1, and 0 for y, so plus 0. 3 times 1 is 3, plus 0 is 0, so I get, or plus 0 is 3, so I get a value of 3 there. If I do the middle one, I have f of 3, comma 0. So that's 3 times 3 plus 0, which gives me 9. And the last one would be f of 1, comma 4. And I get 3 times 1 plus 4, which 3 times 1 is 3, plus 4 is 7. So the minimum would be this first point because the minimum was 3. So the first point gives me the minimum, which is 1, comma 0. And the max point would give me the second one, 3, comma 0. So that tells you that's where the minimum and the maximum of that feasible region lies. Okay. So basically what that tells us is that's the point at the min and the max, giving us a minimum value of 3 and a maximum value of 9. Okay. All right, so let's take a look at number 2. I'm going to get you started on number 2, and then I want you to finish the rest of it on your own. But let's take a look at number 2. We're doing the same thing. Graph system of inequalities, name the vertices, and then find the max and the min values for the region using the objective function. So our three constraints. Top one, x is less than or equal to 2. That means that I have a vertical line at the x value of 2. So I'm going to go over to x equals 2, and I want a vertical line there. So I'm going to get a vertical line that looks like this. The next one, I need to solve that equation for y so that I can graph it. If I have 3x minus y is greater than or equal to negative 2. I subtract the 3x, I get negative y is greater than or equal to negative 3x minus 2. Divide by the negative 1. Inequalities, folks, don't forget to flip your symbol because I divided by a negative. So now it's less than or equal to 3x plus 2. That's what I'm going to graph. So I'm up at 2. Up 1, 2, 3 over 1, or also down 1, 2, 3 and back 1, and then get a line going there. So if I have a line, get red, go with the points. Here we go, kind of like that. And then the last one, y is greater than or equal to x minus 2. So negative 2 is my y-intercept, and then I go up 1 over 2, up 1 over 2, up 1 over 2, and here is the line there. Line, make it blue, and there it is. Okay, so feasible region is in kind of an interesting spot here. Let's take a look and see where that feasible region is. Here's one of the vertices. Here's another vertice, and here's another vertex. Sorry, here's one of the vertex, another vertex, another vertex. And the shading is in the middle. So let's name those 3 vertices. The vertices are I have this one at -3, -5 is what that looks like. And then I have another one of 2, 6. And I have another one of 0, nope, 2, 0. There we go. 2, 0. So those are the 3 vertices. Now I want you guys to go ahead and pause the video at this point, and I want you to plug them into that objective function to find the minimum and find the maximum. Okay, that's going to stop our video for today. Don't forget to hop back to Schoology and take that quiz, and we'll pick this up tomorrow. Have a great night. Thanks for watching.